So today we are going to see the selection sort algorithm. Yesterday we have seen the bubble sort algorithm. In bubble sort we have seen it recursively compare the two elements and swaps according to it, and heavier element goes at the end of the array. But what the issue is, the swapping operations continuously takes place, taking the more memory and more calculations. Now in selection sort, what we do, we select a maximum element or minimum according to your conditions. Let's assume for maximum, select the maximum element and swaps at the right position at the end of the array. Let's see practically on notebook, pen and paper, and explain it. Hello everyone. So let's see bubble sort, how does it works. As you know it compares two adjacent elements and swaps if the conditions agree. As you can see, 64 is greater than 24, so it gets swapped. Here also 64 is greater than 12, it gets swapped. Again here 64 is greater than 22, it gets swapped. 64 is greater than 11, so it gets swapped. And you can see over here at last 64 is at right position, sorted order. So basically we need four swaps to make the 64 last element at the right position. Looking at this, you might not have got an idea that what is the issue. We are swapping multiple things. Can't we do like we compare this element? Suppose can't we do like that? We take 64 as a reference and check each and every element. If it is greater than, then that would be the greater element. Like first of all, find the greater element in the array and then swap to the last element. The answer lies yes. The selection sort comes into the place. What does it do? First of all, it has two loops. It selects the first element as maximum element. Let's assume for our case as maximum element. Okay. Then it iteratively checks if the current element is greater than maximum element, then that element is an maximum indexed element. So it checks for 24, 12, 22, 64. As you can see, none of these is greater than 64, so maximum index will remain as 0. Then we will swap with 0 index, that is maximum element index, with our last element, that is 4. So after that, we can see over here we have swapped 11 and 64. This is only one swap is needed. Again, we will see with one more example. Let's check. Now our array is like this. 64 is at right position now, and this one part is our sorted array. Now let's check another condition. Now maximum index again to the 0. Then it will iteratively check. Now it will compare 24 and 11. As you can see, 24 is maximum than 11, so max index will update it to as 24. Then it will iteratively check for 12 and 22. But 24 is greater than that, so it will swap 22 and 24. So this part of the array, it will get swapped. 24 and 22 will swap. So here will be 24, here will be 22. And this part of the array is swapping. Isn't it magical? Here at one iteration only in bubble sort we need 4 swaps. Here in one iteration we need only 1 swaps. Now that's the case. It has time complexity of big O log n, but it is not a stable algorithm. What does means the stable algorithm? For example, this is our array. This 2 and 2, there are duplicate 2s. After sorting, these 2 might come before first 2, or first 2 can become. But in the bubble sort, it is a stable algorithm. This is not stable algorithm. Let's clear your more understanding with the help of visualization. Hi, welcome back to my screen again. Now we will see a visualization for minimum element. So basically minimum elements will sort from ascending order in the way. First of all, I pointer is pointing at index 0 and finding the minimum element. So 64 is selected as minimum element. Then it compares 64 with 24, and you know that 24 is smaller than 64, so minimum element will be 24. Similarly 24, 12, then minimum element will be 12. Then as you can see, 22 and 12, the minimum element is 12, so it will skip, it will not. And in 12 to 11, minimum element is 11, so minimum element is compared to our current index, that is 64. Similar way, all the operation will be take place. Now array index of 0 is sorted, so now 24 is compared with all the elements and find the minimum element. So we got 12 and 12 is 2. Then again in this way the array is sorted. Now you have seen the visualization. Now let me show you the code of the sum. So basically this is the code of the algorithm. First of all, first loop is iterate all over the array. Then we have find the we have taken a variable minimum index to maintain the current index. Then this inner loop finds the minimum element, minimum indexed element. If we found minimum element index of less not equal to I, then we will swap, and this process takes on recursively. That's all from my side. Thank you for